All right, so you're given this quiz in which you are given the pH 7.40 and you're asked to find the other values. The first value you're asked to find is the pOH. Okay? Well, the easy way to find this one is to know, and you're required to know, that 14 is equal to pH plus pOH. It's important to remember, however, that 14 is considered to be an absolute number. And which means that I can put as many decimal places after the 14 as I want. So 14 is not going to be the number we use to round off with when we're doing the addition and subtraction. Okay? Since we know that the pH is 7.40, then we've got this equation. And just as you were taught in Unit 7 with the gas laws, when you have something like this, all you need to do is isolate the unknown. The unknown is pOH, so in order to isolate that, we need to subtract this value from both sides. If we're adding here, you undo addition with subtraction. So we're going to subtract 7.40 from this side, and we're going to subtract 7.40 from this side. Now the thing to remember is 14 is an absolute number. And this is going to just give us 0, which basically means it goes away. So we end up with pOH on this side. And to properly subtract 14, or 7.40 from 14, you need to remember that you can put as many zeros as you want. So we got 0, 6, and I believe this comes out to be 6 here. And so therefore the pOH is going to be 6.60. Okay? That's how you show all your work. You've justified your answer when you show all your work. Okay? All right, so number 2 then. Let's go ahead and give you points for this. You need to show the equation. You need to show that you substituted the number or the number value for pH into the equation. And you need to have an answer to the correct number of significant digits. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points total for number 1. Number 2. Yes. What? That's worth, did you write 6.60 equals pOH or just 6.60? Well, that's just worth 1 point. Oh, well, pOH? Okay, that would be 3 points then. Okay? Now, number 2 is what's the hydrogen ion's molar concentration? So the symbol for that is this. This is the symbol for the molar concentration of hydrogen ions. The relationship between pH and this number, well, let me back up a minute and remind you that pH is the negative logarithm of the hydrogen ion concentration, or negative logarithm of the hydronium ion concentration. So, since logarithms are exponents, and we have reversed the sign on the answer. That's what this negative in front will do. It just change a positive to a negative or a negative to a positive. Since logarithms, these are all logarithms base 10, logarithms are exponents, then to undo a logarithm, you simply put it on the 10 in the exponent position. Okay? So to find this value then, we're going to take 10 to the negative, 10 to the negative pH. Okay? So we're simply going to plug in the value we need, 10 to the negative 7.40. What's the matter? Shout out. Okay, I got it. Yeah. Okay, if you do the the problem correctly, that's the answer you should get with maybe a few less digits or something on your calculator, depending on the kind of calculator you're using. Now don't, listen, you have to be careful. A lot of students will look at this number and not even write e to the negative 8 or 10 to the negative 8th power. That's part of the answer. This number, 3.98, is 8 magnitudes of orders of magnitude larger. This number, just 3.98, is 8 magnitudes of, 8 orders of magnitude larger than 3.98 times 10 to the negative 8. So you have to have that in there. And so we're going to round it off to 3 digits. We're going to use the same rounding rules we use for multiplication and division. If I started with 3 digits for this number here, then I'm going to have 3 digits in this final answer. I know that's not the actual rounding rules you should use, but that's what we're going to use in this class. And the unit of measurement is molar, and the species is H+. If you said bracket equals that? No, that doesn't mean the same thing. This is like a symbol, like temperature, T for temperature. Okay? Alright, so you got to have the original equation. No, not this one. You don't need this one, I'm sorry. This is the original equation, right here. Okay? Then you plug in the number value, equals, and there's your answer, with the correct order of magnitude, underlining, arrow, rounded answer, order of magnitude, units of measurement, and species. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Number 3 is, what is the hydronium ion molar concentration? Well, the really neat part about this is that the hydrogen ion concentration is the same as the hydronium ion concentration, because this is just how we deal with acids in the Arrhenius theory or system, and this is how we do it for Bronsted-Lowry. Okay, and therefore, the hydronium ion concentration is equal to 3.98 times 10 to the negative 8 molar H3O plus. Okay? So since the question asks what is it, really all you have to do is give me the answer. This number, this order of magnitude, this unit, this species. Now let me ask you this question. Did you write this equals just that part right there? Did you write this? Okay, well, now look, let me give it to you this way. You can also give me the answer this way, because this would be grammatically correct. Okay, that would be grammatically correct if you wrote it that way. You can write it that way. I'm not saying it's supposed to be written that way. Either one of these two ways is accurate. If you give me this, and that means you're saying that the molar concentration of this stuff is this, so you don't really have to put the units and species there to be grammatically correct. So either way you get, do you have this symbol equals this number? Yeah. Then that would be correct here. Okay, so you get 4 points either way. Okay, so let's go back up then, just to be fair on number 2, because if you wrote your answer like this, okay, you don't have to count off the 2 points for the lacking the units of measurement and species. Does that make sense? Because this right here takes care of the units of measurement and the species.
What if you have an asterisk?
You mean like this number right here equals that?
Yes.
It means the same thing. Yeah, mathematically it's exactly the same thing. Alright, so now the next question then is, what is the hydronium ion? No, I've done that already. 1, 2, 3. What is the hydroxide ion molar concentration? So we want to know this value here. Okay? There are two ways to get there. Two ways to get there. Because the POH is the negative log of this right here, then the molar concentration of the hydroxide ion is 10 to the negative POH. So this is one way to get it. Okay? And so we can get this answer here. So that to the negative, well, let me actually put the number in there. Negative, and we said POH was 6.60. And we get 2.511886432 times 10 to the negative 7. Underline all but the first three digits. And this is molar concentration of hydroxide ions. And so our answer then is 2.51 times 10 to the negative 7 molar hydroxide ions. That's one way to get it. The other way to get it is to know that Kw equals the hydrogen or hydronium ion concentration times the hydroxide ion concentration. Since we know that Kw is 1.00 times 10 to the negative 14 molar squared, and we already have found out that the hydronium ion concentration is this number, then what we're trying to find is this. Thank you. And what we're going to do now is just divide both sides by whatever is going to get the unknown by itself. That means all of this cancels right here, and we have the OH by itself. One of the molars cancels out because molarity, M squared, is just two M's multiplied together, so they can't. One of those cancels out. We have one molarity left. I didn't put the line under this molarity symbol. And so now we need to find the answer. So 1.00 times 10 to the negative 14 divided by 3.98 times 10 to the negative 8 and I get 2.512562814 times 10 to the negative 7. Let me round that off to 2.51 times 10 to the negative 7 molar hydroxide ion. So either one of those will give you the correct answer. So let's see how we're going to do the points then. Let's see. If we do it this way, you have to show me the original equation. Then you substitute well, we don't need it. That number actually has to be negative. Then the unrounded answer, order of magnitude, rounded off, final answer, order of magnitude, molar hydroxide ion concentration. Okay? It comes out to be, doing it this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 points. Let's see if I get 14 points doing the other one. We'd have the same number of points either way, don't we? 1, 2, 3, 4, 5, 6, 7, 8. Let's see. Now let's keep the order of magnitude in here. And then cancellation here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that's 22 points that way. So let's combine some things then. I need to take 6 points out. Let's make all of this correctly written worth 1 point. And all of this correctly written worth 1 point. So that would be taking out 1, 2, 6. That's 6 points? Okay. So 1, 2 because we're canceling. 3, 4 because we're canceling. 5, 6. 7, 8, 9, 10, 11, 12, 13, 14. Okay, that'd be 14 points by doing it that way. Alright? So the total for the whole thing then, let's see, we got 13 plus 15. You already did the math? 46 points total for everything? What is going on here? How long has that been up on the screen? Right there? Just got there? Okay. Anybody need to see the bottom still? All together, the whole quiz is worth 46